All right, so now we're going to start section 3. So chapter 3, section 3, we're going to start talking about exponent properties or rules. You'll hear teachers call them different. I always learned them as properties. So we're going to focus right now on exponents and multiplication. And so I want to say this now. There are 3 videos to 3.3, and the reason is we're going to talk about 3 different rules. So I'm going to give each of those rules its own video. So first property, it's called the product property. And with all of these, we're going to be talking about any integer, helps if I could spell today, integer a and b where a does not equal 0. All right, so for any integer a and b where a does not equal 0, a to the nth power times a to the nth power. I don't know why I chose b. I guess really this should be any integer a, m, and n, now that I look back at this. All right, so just a quick reminder, powers are the whole thing. So this whole thing is a power. My m in this picture up here, that's an exponent. I'm going to call it expo. And the a is a base. And to remember that, think cheerleading. The base holds up the flyer, so our base is holding up our exponent. So in this case, a is our base. If we have that same base, so here we have a to the nth power times a to the nth power, the base stays the same, and we add our exponents. So why does that property work? Well, remember that a power just means the number of times we multiply something times itself. So if we have a to the 3rd power times a to the 2nd power, that's the same as saying a times a times a times a times a, right? And so we have all of these actually multiplying together. This set of parentheses is a cubed, and this one's a squared. And all together, when I add them all together, that ends up being 1, 2, 3, 4, 5. And so instead of writing this out each time, because that's going to be the truth of it, we can just take the fact that a to the 3rd plus 2 is equal to a to the 5th. And so that's our property. As long as we are multiplying the same base, we add the exponents. So if you wanted to write that down, multiply same base, we add the exponents. So let's go through some examples. Problems like this example A get students, because we see this as 5 squared times 5 to the 8th, and we want to take the 5 times the 5, hold out and resist that urge to take 5 times 5. The base stays. So I'm going to keep base of 5. No, go away. I'm going to keep the base of 5, and I'm just going to take 2 plus 8. So then I end up with 5 to the 10th. And as much as you are going to hate this, I want that step. Show me 5 to the 2 plus 8. And later, we can take that out. But for now, especially when this is your problem, you can show me 2 plus 8. It really isn't that hard. But 5 to the 10th is our answer, and we're done. All right, so when I look at B, all three of these have the same base, x, x, and x. So I'm going to have x, and they're all being multiplied. So we're going to take 3 plus 5 plus 10. And so that is going to give us 3 plus 5 is 8, 8 plus 10 is 18. So we'll get x to the 18th power. And again, I want to see this step right now. Now, C is a little different. Our base, and this is what we need to remember, our base is just the one number or letter holding up our exponent, unless it's in parentheses, and we'll see that in a little bit. But the 2 is not part of my base. It is its own base. And the 5 is not part of my base. So I'm going to think of this as 2 times 5 and m to the 10th times m squared. So I'm just going to use the commutative property, which means that we can change our order when adding or multiplying, and move things around. So 2 times 5 is 10. And then we have m to the 10 plus 2. So our final answer is 10m to the 12th. So again, the numbers do not, if they do not have an exponent with them, they do not have an exponent. You can multiply them together. The m was my only base in this problem. So that is it for our first property. So again, if we are multiplying with the same base, we add our exponents. And that is it. I will see you in example, or not example 2, but in our video number 2.